Very good morning, friends. Today we are going to study about most important topic, which is taken from the electromagnetic induction, which is known as motional EMF. Motional EMF itself is EMF produced through the motion of the conductor, right? So if you see, we have taken a magnetic field which is directed inside to the plane. A conductor which is moving in magnetic field, it is actually cutting the flux which is available due to the presence of the magnetic field, right? So according to the Faraday's law, what is the magnetic flux? Magnetic flux phi is equal to BA. If you see what is the area, area is actually length into width. Length is the conductor's length L, and what is width? Width is the distance which is being covered by the conductor in the left side. So phi is equal to BLX, correct? So what will be the EMF? E is equal to minus d phi over dt according to the Farad law. So minus d over dt if we are placing, so phi is equal to, if we are going to place here, BLX. If we are going to differentiate x with respect to t, then B and L will be the constant. So it will be taken outside. B and L has been taken outside, and minus sign is already here. But one thing is there, actually in this process, x is going to decrease. So we will take x minus. So it will be minus dx over dt. So it will be what? Minus and minus will be plus BL dx over dt. So it will be BLV. So what is the value of the motional EMF when a conductor is moving in magnetic field and it is actually sweeping the magnetic flux? Then you will getting the EMF as E is equal to BLV, correct? So this is actually important topic, and with the modification of this topic, each and every year they are asking question in JEE Advanced, JEE Mains, and even in NEET exam also. So we'll look at some examples so that we get more clarity in this topic. Look at here. This is the EMF across rotating straight conductor. EMF across rotating conductor. This is EMF across the conductor. We will take here. Suppose that this is a conductor and it is rotating in a magnetic field which is being directed into the plane. First of all, we are going to take a small portion over the rod that is depicted with the dx, and distance from that particular portion from its origin is x, and total length of the rod is L, correct? So right, so look at here. If we are going to find its EMF, DE is equal to, so what will be DE is equal to? Right now we have seen E is equal to BVL, right? So it will be B magnetic field, product of velocity into magnetic field, dot product of the distance whatever you have taken from its center. So you can write here DE is equal to minus V B dx. Dx is nothing, whatever we have taken in earlier section, that is L. So you can see here cross product of B and V will be opposite to the dx. So that's why we have taken here minus sign here. Okay, hopefully this is clear for you. So if we are going to integrating the section DE is equal to minus V B dx, then what will happen? Actually we have to take one negative sign. So this is 0 from 0 to L. Actually, you are going to get integration. So it will be E, and what will be its limit? Lower limit is 0, upper limit is L. L or capital, whatever you are taking, that's up to you. One thing is there, this is actually rotational motion. In rotational motion, you know that V is equal to what? V is equal to R omega, or V is equal to omega x, correct? So at place of V, we can write here omega x, yes? So write down here minus omega x B dx. So you can take omega and B outside. Omega and B you can take outside, minus omega and B you have taken outside, that will be x dx, integration of from 0 to L. So that will be minus omega x minus omega into B, and that will be x square by 2. That is from 0 to L. If we are going to replace the x with 0, upper limit is L, lower limit is 0. So it will be what? Minus half of B omega L square. That will be the EMF which is produced across the conductor, and conductor is rotating in a magnetic field. Actually, minus sign is representing here the direction, but if we are not going to take the direction, only we are going to take the magnitude, it will be half of B omega L square. Hopefully it is clear with you. Now look at here, what is actually going on here. If you are going to take conductor, taking conductor in this way, right? This is the A point, and it is rotating with omega. So what will be there? There will be two terminal developed across the AB. This is, we have taken AB here. This will be positive and this will be negative. So how much you will be getting EMF here? E will be half B omega L square, right? Hopefully this is correct for you, clear for you. Now, what about the electric field? Electric field at any point in the rod. Electric field is going to develop across the rod. Across the road. It will be what? We know already that dVBA will be what? Minus V dx VVL, right? This is equal to what? VVL only. So, and one thing you know, what is the relation between electric field and electric potential? E is equal to minus dV over dr, correct? So we can write here E is equal to dVBA upon dx. That will be direction from B to A. So I'm writing here due to less space. E electric field is equal to minus V B dx over dx. Dx and dx will be cancelled. So it will be what? That will be B omega x. So actually you are taking direction here. This is with the direction, and if we are going to take magnitude, it will be V omega x. So it will be the electric field developed into the conductor at any point, and it will be decided through the x. Suppose that if you are going to find out electric field at L by 3 part of the rod, so just x will be replaced by the L by 3. That's it. So now, friends, you can see how IIT JEE is going to ask question from this particular section. Okay, look at here. These are very interesting topic and not much difficult. Look at here. Look at this question. What they are asking, a horizontal straight conductor wire of 5 meter long extending from east to west, free falling at right angle to the horizontal component of Earth's magnetic field. Earth's magnetic field means BH. BH is how much? 0.6 into 10 to power how much? -4. And instantaneous value of EMF induced in wire when its velocity is, they have given the velocity. So velocity they have given, that is 10 meter per second. What is the length of rod? Length of rod is 5 meter. Guys, look at here. They are going to, they have asked question in 2024 only. This is not very long ago. So we can find out here EMF is equal to, E is equal to, again the same thing, BH, B, V, L. I'm sorry, this is V, not omega, VBL. 0.6 into 10 to power -4. 10 into L is how much? 5 meter. So you will be getting, by solving this, you will be getting 3 into 10 to power -3 volt. That's it. Correct? So this is easy topic, but important one. Look at here. Look at the next question. This is the, a metallic rod of length L is tied to the string of length 2L and made up of rotate with angular speed of omega on a horizontal table with open end of string fixed. Look at here. String is fixed here from, no, from origin to this point. From origin to this point, they have given its length as 2L. String length is 2L and rod length how much? Rod length is L. Rod length is L. So look at here. They are going to ask about the EMF developed across the rod. Induced EMF across the end of the rod. From here to here, from this point to this point, they are going to ask what will be the EMF. So this is again very easy question. You can solve it like that. Actually, this whole system is rotating. This spring and the rod is rotating in this plane with omega. Okay, so what will be the EMF? EMF will be for the complete, due to the complete system. So for this, we are going to take a small area, a small section over the rod, that is dx. Okay. So we have already discussed here about its string length is 2L and this is this particular portion is dx. So dE will be what? B omega x dx, because we are taking a small section only. So if we are going to integrate this one, dE is equal to B. Omega also you can take outside. There will be x dx. Okay. How much rod length will be up? This is up 2L and here this will be 3L. So from 2L to 3L you have to take its integration. So it will be omega b omega by 2 and it will be x square and lower limit is 2L, upper limit is 3L. So it will be how much? B omega by 2, that is 3L square. This is complete 3L square minus 2L complete square. That will be B omega by 2 and this will be 9L square minus 4L square. 9L square minus 4L square. That will be 5L square B omega by 2. Correct? So this is third option from this section. Correct? We are moving for the next question. Look at here. This is the next question. Look at here. This is from JEE-mains 2024 question. A square loop of side 15 centimeter being moved towards the right at constant speed of 2 centimeter per second. What they are asking, constant speed. Speed is not going to be changed. So it is 2 centimeter per second. The front edge enters the 50 centimeter wide magnetic field at t is equal to 0. Then value of induced EMF in the loop at t is equal to 10 seconds. So if t is equal to 0 seconds, at t is equal to 0 second, it's outside of the magnetic flux or magnetic field. Then what will be its position at t is equal to 10 seconds? It will be inside the magnetic field. So if complete loop is inside the magnetic field, then what it will say? What will be the change in magnetic flux? Change in magnetic flux will be 0 at t is equal to 10 seconds, right? So what will be the EMF across its end? So we can say that EMF across its ends will be 0 only. What will be there? VLV, VLV, right? So this is E is equal to d phi over dt. That will be 0 only. So what will be the EMF? E is equal to 0. So this is very easy question they have asked in mains, JEE-mains 2024. Correct? Next, we are moving for the next one, important question, that is using the concept of magnetic field when a loop is rotating in this one. This is JEE Advanced 2023 question. Look at here. A wire which is carrying a current of 10 ampere and one of the loop that is located at d distance and its length is 2 centimeter, width is 4 centimeter. Its x and y direction position they have given already. Length of loop is how much? 4 centimeter, width is 2 centimeter, and they have given the resistance also. What is, they have given the loop resistance also, that is 0.1 ohm. So we have, if we are going to find the induced EMF, induced EMF E is equal to what will be there? Induced EMF, look at here. Induced EMF will be what? This will be change in magnetic field B1 minus B2 into X into By. Now you will ask why we are taking the difference of magnetic field. Why? Because we are getting magnetic field due to two portions at this position. From this part we are getting one magnetic field, from this part we are getting one magnetic field. So we will be getting here difference of B1 and B2. Correct? So E is equal to the same thing, BVL. This is equal to L. This is equal to velocity. And this is the difference of the magnetic field. So if we are going to find the induced current, I is equal to what is that? E by R. And what is E here? Mu naught I upon 2 pi R into what? Into, look at here very carefully. Look at here. 1 by d minus 1 by d plus y. Right? 1 by d minus 1 by d plus y. And what is that? X into Vy. This is magnetic field. This is the L and this is the velocity. Whatever we have taken here, no, I'm talking here about that one only. And you have divided by the R itself. So look at here. They have given a current of how much? 10 to 10 micro ampere. So current will be how much? 10 to power minus 6 ampere. And this will be 4 pi, because mu naught upon 2 pi they have given, 4 pi into 10 to power minus 7 divided by 2 pi into 10 into what? 1 by 4 minus 1 by 8 into 2 into Vy. So Vy, they have given how much? 2. So if you are going to find out the tan theta, that will be Vy by Vx. So it will be 1 over root 3. If we are going to find out 1 over root 3, then we can find here Vx is equal to Vy into root 3. So Vy they have given already 2. So it will be 2 root 3. Then what will be the resultant velocity? Resultant velocity, it will be 2 root 3 square plus how much? 2 square, that will be under root 16, that will be 4 meter per second. That is our answer. So look at guys, they have asked question in a very wide and spread manner. But if you are focused at your concept, then you can solve it in a very smooth manner. So these are the concept from the electromagnetic induction and basically from the motional EMF itself. Look at guys, next question. This question is saying that as shown in figure, a metallic rod of linear density they are giving 0.45 kg per meter in lying horizontally on a smooth inclined plane, which is making an angle of 45 degrees with horizontal. The minimum current flowing in the rod required to keep it stationary. This rod, they want to keep it stationary. So what will be the current flowing in this particular loop? Magnetic field is acting vertically upward. So we need to find out the electric current here. So how? Look at here. We are going to make its horizontal and vertical components. Look at here. Suppose that this is the metallic rod. This is a side view of metallic rod. So, and this is the angle theta here. Likewise, this is its mg, and this will be acting as what? It's a FB. Magnetic force FB is equal to BIL. It will be FB cos 45, and it will be F, not F. This is mg sine theta. Okay. So you can balance out here. Mg sine 45 is equal to what? FB cos 45. And this is what? This is what? 0.45 L into G is equal to what? BIL. So you can find out here I is equal to how much? 0.45 into 10 upon how much? 0.15. If we are going to solve it, that will be 30 ampere. This is they have used here Newtonian mechanics along with the induced EMF and motional EMF. 3 concepts in a single question. This is the beauty of actually IIT JEE questions, right? Hopefully you are agreeing with this one. So guys, we are going to learn next type of question from this section, that is when conducting rod is rotating in a magnetic field, right? Then what will be the induced EMF across the rod? Look at here. Rod is fixed at this point, and it's a P terminal is free to rotate in this particular magnetic field. Okay. So how much EMF will be induced? Find the induced EMF across the ends of the rod. Especially they are talking about the induced EMF produced across the P and Q. So look at here. We are going to find out the induced EMF. So induced EMF, induced EMF will be DE. DE will be what? V dx sine theta. That is VL sine theta only. Nothing more than that. Here, theta is the angle between which one? Dx and B. Are you getting this point? Yeah. So E is equal to DE. That is, you can take B omega sine square theta, and that is x dx. From where? From 0 to the total length of rod, that is capital L. So that will be what? Half B omega sine square theta L square. This terminal will be at positive point and this terminal will be at negative point. Why? Because if this rod is rotating in this plane, then what will happen? If rod is rotating, then electrons will move from point O to the point P. So this will be if electron is moving from a point that is positive at positive terminal and this is negative terminal. So this is EMF induced across a rod rotating in a uniform magnetic field. So hopefully guys, you have understood about the concept of motional EMF in different scenarios, like we are taking rod in magnetic field, rod is rotating in a magnetic field, rod is rotating on an inclined plane, and when a rod is placed in magnetic field in any particular situation. So thank you so much guys. This is the concept of the induced EMF across the rod. It may be for the ring, disc, and it can be applied at any particular shape and size of the conductor. So see you guys in next session. So up to that, thank you so much.